Have you ever looked up at the night sky and felt a sense of wonder? The sheer scale of it all, the countless stars, the swirling galaxies. It feels so real, so permanent. But what if I told you that according to the laws of physics, none of this should be here? Not the stars, not the galaxies, not even you. This isn't science fiction. It's one of the deepest and most unsettling puzzles in modern cosmology. The very existence of our universe hangs by a thread so fine, it's practically non-existent. Let's start with something called the cosmological constant. This is a value that represents the energy density of empty space. When Einstein first developed his theory of general relativity, he added this constant to make his equations describe a static, unchanging universe, which was the prevailing view at the time. When it was discovered the universe was expanding, he famously called it his biggest blunder. But here's the twist. It turns out he was right, just not in the way he thought. We now know that the universe's expansion is not only happening, it's accelerating. And the cosmological constant is the best explanation we have for this mysterious dark energy driving it. Here's where it gets strange. Our best theories from quantum mechanics predict what the value of the cosmological constant should be. But when we compare that prediction to the value we actually measure from observing the cosmos, there's a disagreement, and it's not a small one. The predicted value is off by a factor of 10 to the power of 120. That's a 1 followed by 120 zeros. To put that into perspective, that number is larger than every atom in the known universe. If the cosmological constant were as large as our theories predict, the repulsive force of empty space would have been so immense that it would have ripped the universe apart in the first fraction of a second. Atoms would never have formed. Stars would never have ignited. Galaxies would have been impossible. The universe would be a cold, empty void. On the other hand, if it were even slightly more negative, the universe would have collapsed back in on itself before it ever had a chance to get going. Our existence depends on this number being inexplicably, exquisitely small and precise. But the cosmological constant is just one piece of the puzzle. Let's talk about the fundamental forces of nature. Then there's the electromagnetic force. Its strength relative to gravity is perfectly balanced. Gravity is incredibly weak compared to electromagnetism, about 10 to the power of 36 times weaker. This might seem like a huge imbalance, but it's crucial. Because gravity is so weak, stars can grow to enormous sizes before the inward pull of gravity overcomes the outward pressure of nuclear fusion. This allows them to burn for billions of years, providing the stable energy needed for life to evolve on orbiting planets. If gravity were just a little bit stronger, stars would be much smaller, hotter, and burn out in a few million years, not nearly long enough for complex life to emerge. Even the masses of the fundamental particles seem fine-tuned. Take the neutron. It's just a tiny bit heavier than the proton, about 0.14% heavier. This slight difference is critical. If the neutron were just a little lighter, it would be the proton that was unstable. Free protons would decay into neutrons, and the universe would be devoid of the atomic building blocks we rely on. If the neutron were slightly heavier, they would have decayed so quickly after the Big Bang that complex nuclei could never have formed. Again, no elements beyond hydrogen. The balance is so delicate that it's like balancing a pencil on its sharpest point for 14 billion years. So what are we to make of this? We have a set of universal constants and quantities that seem to have been dialed to incredibly precise values to allow for the existence of a complex, life-permitting universe. If you change any one of them by even a small amount, the resulting universe is sterile and lifeless. Physicists call this the fine-tuning problem. It's the observation that our universe appears to be a statistical impossibility. There are a few ways scientists try to grapple with this. One idea is that it's just a cosmic coincidence. We won the cosmic lottery. The values are what they are, and we just happen to live in the one universe where they permit our existence. This is known as the anthropic principle. It suggests that if the universe were any different, we wouldn't be here to observe it, so we shouldn't be surprised to find it's hospitable to us. But for many scientists, this feels unsatisfying. It doesn't explain why the constants have these values. It just states that they must. Another, more mind-bending possibility is the multiverse. This theory suggests that our universe is just one of countless universes, each with its own set of physical laws and constants. In this vast cosmic landscape, it's no longer surprising that at least one universe would have the right conditions for life. We are simply living in one of the lucky ones. While this is a compelling idea, we currently have no way of testing it. We can't see or interact with these other potential universes, so for now, the multiverse remains a fascinating but speculative hypothesis. A third possibility is that there is some deeper, undiscovered theory of physics, our theory of everything, that explains why these constants must have the values they do. Perhaps they aren't random at all, but are mathematically required to be this way, linked by some underlying principle we haven't yet found. This is the great hope of many physicists, the search for a single, elegant framework that unifies all the forces of nature and explains the fundamental constants from first principles. But until that day comes, we are left with a profound mystery. The universe we inhabit, with its beautiful spiral galaxies, its blazing suns, and its intricate web of life, appears to be built on a foundation of impossible coincidences.